Today is day 25 of Python Pro from CTC. Today we are learning linked list in Python. Linked lists are dynamic data structures that provide an alternative to traditional arrays or lists by storing elements in nodes. If you are curious about how to efficiently manage and organize data in a flexible way, you are in the right place. So what exactly is a linked list? A linked list is a linear data structure where elements are stored in nodes and each node points to the next one in the sequence. This linking allows for dynamic memory allocation, making it easier to insert or remove elements compared to static data structures like arrays. The basics. Here we are going to compare lists and linked lists. Lists in Python are implemented as dynamic arrays. They are contiguous blocks of memory. Memory is allocated for a fixed capacity and the list may need to be resized when the capacity is exceeded. For example, here we are trying to insert a number 4 in the array, but if we are trying to do that, we have to swap out all the elements to the next memory location. As you can see here, the array is full, so we are going to not only swap out the elements but also resize the whole array. So this is not so efficient. But linked lists, on the other hand, they use dynamic memory allocation for each node. Nodes can be scattered in the memory and they don't require contiguous memory blocks. Each node in a linked list has an additional pointer contributing to more memory overhead compared to a list. As you can see here, this node is located in the memory location 1019, this in 1001, 1112, 1357. As you can see, this is not a contiguous memory, right? So this whole thing is a node. A node got two parts. So one part is the actual data we are going to use. The next part is the pointer, which is going to point us to the next memory location, that is the next node. That's why we call it a linked list. We are having a link between every node. But what do we have at the last node? We have a null, meaning we haven't, like, that node isn't pointing to anything else. So as you can see here, insertion and deletion at the beginning just cause O of 1 and insertion deletion at the end cause O of n, cause we are going to iterate through all the nodes. Same goes for traversal and accessing an element. In lists provide constant time access to elements using indexing. Appending elements to the end of the list is efficient. Insertion or deletions in the middle or at the beginning of the list are less efficient, especially if the list needs to be resized. But in linked lists excel at insertion and deletions, especially at beginning and end. Accessing elements by index require traversing the list from beginning, resulting in linear time complexity. As you can see, if we are going to locate to this node, we have to go to this node, then this, then this, then we will get this. So we will get linear time complexity. Random access is less efficient compared to lists due to the lack of constant time indexing. So let's say if we are trying to insert an element here, what we will do, we will just change the pointer here and point it to the location where we are going to store the next node, and we will change the pointer to the next element. This is the another type of linked list called doubly linked list. As you can clearly see here, this is not a surprise when you know what is a linked list. So here we have got the pointer to the next location. This goes on till the end. But what do we got in the front? We got the pointer to the previous element. See, previous element. Again previous element. So this is called a doubly linked list. There is also a thing called circular linked list. It is also like singly and doubly linked list. But at the end we won't have this null pointer. Instead of that, we will have a pointer pointing to the first element here. So that is called a circular linked list. Simple Python implementation of linked list. Here we have got two classes, the node class and the linked list class. The node class represents a single node in the linked list. Each node has a data attribute which stores the value of the node and the next attribute to reference the next node in the sequence. And the linked list class. Linked list class represents the linked list itself. It has a head attribute in its constructor which points to the first node in the linked list. Initially it is set to none as the list is empty. We have got the print method here. So here we are checking if self.head is none, cause the first element, the first node of the linked list is none. We have got nothing in the linked list. So we will just print linked list is empty. Or else we will create an iterator. First we will assign it to the first node. We have got a linked list string. We will iterate the iterator variable through the next elements. So we will use itr equal to itr.nextstop. We will store everything as string in the list string. So this arrow mark is going to point the nodes to the next in the sequence, and then we will print the whole string. That is, we will print the whole linked list as a string. Then we have got the getLength method. In the getLength method, what we are going to do, we will first initiate a temporary variable called count, and we will assign it as 0. Then the same thing, we will iterate, then count will be added, increased for every iteration, then we will just return the count. We have got the insert at beginning method. The insert at beginning method inserts a new node with the given data at the beginning of the linked list. It creates a new node with the provided data and sets its next attribute to the current head. That is, what we are doing here is we will just pass the data and we will create a node, and we will pass the data and self.head as its pointer. This, it will point to self.head. That is, it will point to the first element, because we are making the first element as a second element. And what we are going to do, we are going to make self.head as node. That is, we will make this node as the first element here. Insert at the end method. So what we are going to do here is we will first check if the linked list is empty. If the list is empty, the last element is going to be the first element when we add a new element, right? So if self.head is none, self.head is node of data and the pointer is null, and we'll just return it. If not, we'll use the iterator again and we will iterate it till the last node. Then we will assign iterator on next equal to node of the data and it will point to null. Insert at method. Insert at method is used to insert a new node at a specific index. So we will pass the data along with the index. First we will check if the index is valid. So if the index is less than 0 or greater than the length of the linked list, we will just raise an exception. Or if the index is equal to 0, that means we are just inserting a new node at the beginning. So we will call the insert at beginning method. If the index is not 0, we will initialize a counter and create an iterator starting from the head of the linked list. We will iterate through the linked list using a while loop. Inside the while loop, we will check if count is equal to index minus 1. This means we have reached the node just before the desired insertion point. So then what we will do, we will create a new node, that is node equal to node of data comma iterator next. That is, with provided data and set its next attribute to the node currently at its index position. Then we will update the next attribute of the current node to point to the newly created node. So we have inserted the new node here. If we did, we will just break it, or else we will iterate till we get to the correct index. Similarly for the remove function. Remove will just remove node from in a specific index. So we don't have to pass any data here. We will just have to pass an index. First we will check for the same thing again. If the index is 0, simply update the head to point to the next node in the list. This effectively removes the first node. That is, this was the first, the first node is now the next node. So the first node is out of the game. Next, if the index is not 0, we will initialize a count and then we will create an iterator starting from the head of the list. We will again iterate using while loop. We will check if the count is equal to index minus 1. This means we have reached the node just before the desired removal point. Update the next attribute of the current node to skip the next node, effectively removing the node at the index. That is, so let's see this as an example. So here we are trying to remove this node, which is located in 1001. So this memory location is pointing to 1001, right? But what if we change this pointer to this location? That is, we'll just store 1112. That is 1112 here. Then this will point directly. This will point directly to this node. So this node in the middle goes out of play. Here is the next pointer is assigned as the next of the next pointer. If we do this, we will just break it out, or else we will again iterate it. Here we have got the insert values method. That is, we are going to insert a list of values. So again, like, we will just completely eradicate the whole linked list here. So self.head is equal to none. For data in data list, cause we are passing a data list here, we will iterate to the data list. For every data, we will use insert at end, so everything will be added at the end. Block of the whole code. If dunder name equal to dunder main, we will just use the linked list class and we will use insert values, which will insert data at the end from the whole list, and we will just print it. Let's see how this goes. So we got them in order correctly: banana, mango, grapes and orange, and here banana, mango, grapes and orange. Again, what we are going to do, we will just remove the whole thing and we will insert something at the beginning. Let's try to insert something at end 45. Again, we will insert something at the beginning. Let's say 10. Let's see how this goes. We got 45, we added at the end. We got 6, which we first added at the beginning. Then we added 10 at the beginning, at the last, as you can see. 6 at the beginning, then 45, 6, 45. Then before 6 we should get 10. We have got 10 here. We'll try to insert 10 at some index. So we'll insert it at 1 for 1 index. So we'll use insert at method. So what we are going to do, we'll just run it, and we got 10 at the first index. That is second question. 6, 10 and 45. Try get length and remove methods here. The same linked list. Then we have printed it. Then we have got the length of it. Then we have removed the element at the first index. Then what we will do, then we will just print it. Then we will give the length of it. It will just return the length. So print of ll dot get length of So let's see. So the same linked list, we printed the list, we got the length as 3. Then we removed 10, which is in the first index, cause we removed the node from the first index. Then what we did, we printed it. So as we removed 10, the length will be 2 here.